All right, let's talk optimization. Basically the art of doing as little work as possible without getting fired. You know, like politicians. But unlike politicians, programmers are actually useful. You see, optimization isn't just a fancy buzzword managers toss around. It's a lifesaver in computing. It's about spotting unnecessary steps and cutting them ruthlessly. Take the Fibonacci sequence. You remember that irritatingly persistent set of numbers that haunt computer science students like their overdraft? The sequence where every new number is the sum of the two before it? Yeah, that one. Now here's a shockingly simple observation. To calculate any Fibonacci number, you don't need to remember every number that came before it, just the last two. It's like listening to someone boring talk at a party. You don't really need to remember every detail, just smile, nod, and occasionally say, "Oh, fascinating," while remembering only the last few words to repeat back convincingly. By doing this, we massively reduce the memory our computer needs, keeping things as minimal as possible. This trick reduces our space complexity dramatically, meaning no matter how large a Fibonacci number you're calculating, your computer's memory stays as stable as a Buddhist monk during meditation. You might ask, why bother? Memory's cheap nowadays. Well, mate, tell that to someone using a 10-year-old smartphone, or worse, one of those embedded devices that has the computing power of a potato clock. In such cases, every byte counts. This optimized method is perfect if you're on a device with limited memory, like that vintage Nokia you're stubbornly clinging onto. You're dealing with massive Fibonacci numbers and you don't want your computer collapsing like an England football fan during penalties. You only care about one Fibonacci number, no need to remember the entire tedious sequence. You're an efficiency maniac who loves optimizing things for the sake of it, because honestly, who isn't? Imagine you're trying to remember a phone number, but you're shockingly bad at it. What do? Write it down on your hand, of course. But here's the twist. You've only got space for two numbers. Tricky, right? Well, not really. You just keep rewriting these two numbers as new ones come in. Problem solved, memory saved, job done. That's exactly what we're doing here. Instead of holding the entire sequence in memory, which is pointless and wasteful, we just keep track of the two numbers we actually need, the previous two Fibonacci numbers. Each time, we use these two numbers to calculate the next one, then update them and carry on. It's the computational equivalent of scribbling numbers on your hand, rubbing them off and scribbling again over and over, only significantly less unhygienic. So let's walk through this using a small number like 6, because I'm considerate like that. Start with our two basic ingredients, 0 and 1. Congratulations, you've mastered step 1. Add these two numbers together, giving us 1. Now our two numbers are 1 and 1. Next, add those again and we have 2. Update our numbers to 1 and 2. Then we add these, 1 plus 2 gives 3. Update to 2 and 3. Add again 2 plus 3 gives 5, and update to 3 and 5. Finally, one more time, 3 plus 5 equals 8. There we have it. The sixth Fibonacci number is 8, calculated effortlessly with about as much memory usage as your goldfish. All right. Here comes the boring but essential technical bit. Bear with me. This method only takes linear time, meaning if you double your input number, it just takes twice as long. Predictable, manageable, lovely. It uses constant memory, meaning no matter how large your Fibonacci number is, your computer doesn't freak out and crash, unlike your web browser when you open more than 3 tabs. You only ever need 3 variables, the 2 most recent numbers and the current one you're calculating. Minimalist and elegant, like IKEA furniture, but without the missing screws. Beginners love this optimized method because it's crystal clear. No recursion, no complicated structures, just simple iteration. They get to feel clever by using minimal resources. It teaches brilliant coding habits like minimalism and elegance early on. They quickly see results and efficiency improvements, boosting morale and making them feel less inadequate. It's like cooking a fancy meal that only uses 3 ingredients, easy, satisfying, and makes you look surprisingly competent. Let's quickly compare this method to others we've painfully explored. Naive recursion, horrible, slow, eats memory faster than a teenager eats crisps. Iterative with an array, better, but wastes memory by storing the whole sequence. This optimized method, perfectly efficient, fast, minimal memory, and won't embarrass you at parties. Basically, if efficiency and minimalism had a love child, it'd be this method. This isn't just about Fibonacci. It teaches vital lessons, how to simplify problems by spotting unnecessary complications, smart ways to manage limited resources critical for real-world applications, how to refine algorithms progressively to their simplest form, recognizing the minimum information needed to solve a problem. These skills aren't just useful, they're essential. They're like learning how to cook, change a tire, or pretend to care during meetings. Here's a delightful challenge for students. Try modifying this algorithm to also output the full Fibonacci sequence. You'll quickly discover why this optimization is both brilliant and slightly inconvenient. Because by optimizing for one thing, you've made another slightly more annoying. This lesson highlights a crucial computing truth. Everything is about trade-offs. Optimize one thing, complicate another. Welcome to life. So we've learned optimization can dramatically simplify problems. Minimal memory usage can coexist with maximum efficiency. Iterative Fibonacci calculation using just 3 variables is elegant, powerful, and incredibly efficient. Good coding isn't just about making things work, it's about making things work beautifully and simply. Next time someone complains that programming is complex, show them this. If they still don't get it, maybe reconsider your friendships. Next time, advanced techniques, because you're now officially a nerd.